Yay for technology. Good evening. This is Tobias Engel from CCC, and the topic is locating mobile phones using signaling system 7. Interesting technology and very interesting usage of it. So give me your hands for Tobias, please. Thank you.
Try it again. Test 1, 2. Oh, okay, much better. Okay. Yeah. What's with the feedback? Better now? Can you switch off the other mic? Okay. So I'm going to start anyway. So I would like to start with a demonstration of what I'm going to talk about. So is there anybody in the audience who would dare to come up here and enter his preferably non-German mobile phone number into this web form? I promise nothing bad will happen to your phone, and or better yet, nothing at all will happen to your phone, and the number will not be shown in full on the. Come up here. Okay, great. But I need to know the number. I don't need to have the phone. I just need to know the number. So just come up here and enter the number. No, it's not. We won't see the number. And please enter it in international format with +44.
Sorry, I have to.
Yeah. Okay. So, can we do anything about this feedback? Okay. How do? Yeah. Okay. Let's see. Okay. Thank you very much. Okay. If there's somebody who knows something about this technology.
Not yet.
Okay. So, let's see if this works.
Oh, there's missing a. Oh, shit.
Oh, I also forget something. Okay, come up here again. I have to disconnect this for a second. Okay. Once again.
Okay, just edit without the.
Yeah, okay.
Otherwise, it's my fault.
7.
I called just.
Plus is not important here.
All right.
Okay.
Should be the right one. It's showing up.
Okay, so he entered his UK phone number. As you can see, it starts with +44. And yeah, the most thing to notice here is his current location is correctly displayed as Germany, Berlin area. So yeah, this is practically what I'm going to talk about. You could enter almost any mobile phone number here from anywhere in the world, and it would show at least the country where it's currently roaming, and probably also the city. So it doesn't get any better than city level, but yeah, at least that. Also, we can see the IMSI number, and yeah, we get to that later. So let's start. First off, what is signaling system number 7? It's a suite of protocols used by telecommunications operators in the whole world to talk to each other. So that means if I want to call you, then I dial your number, and the switch that my phone is connected to talks to the switch that your phone is connected to and says, hey, I have a call here from this and that number for that number, and please put it through. And this communication takes place over one of the SS7 protocols. So it's standardized by the ITU, and when it was designed, I think something like 25 years back, there were only very few telecoms operators in the world, and most of them were either state-controlled or big corporations, so they trusted each other, and so no authentication whatsoever was built in. So everybody could just say, hey, I'm that operator, and I'm from here, and the other end would trust whatever it said in those sender address fields. And much like with IP, where you can put any IP address and there's probably no way to verify it. So yeah, today almost everybody can be an operator. For example, all the voice over IP operators that are around now, and so SS7 access is much easier to get today. So SS7 is divided into several parts. One of them, the most interesting for us today, is the mobile application part, or MAP in short. That was specified a little bit later because mobile phones are still pretty new. And that specifies additional signaling that is required for mobile phones. So of course you need different kinds of signaling when you suddenly can take your phone with you to other countries or other areas, and you can send messages around and all kinds of stuff. So, and yeah, for two network operators to talk MAP to each other, they need a roaming agreement. So that means, well, you can't log onto a network where your network operator doesn't have a roaming agreement with. So there always have to be, every network operator has to have roaming agreements with every other network operator that he wants his phones or his customers to be able to log into. So just a very simplified structure of a GSM network. Yeah, I try to make it as simple as possible. So on the right-hand side here, we have the home location register. It's practically just a database that holds your subscription data, meaning it knows your phone number, it knows your SIM card number, it knows what calls you are allowed to do, and if you are allowed to enter call forwarding and stuff like that. So then there is the visitor location register, which always has a copy of your subscription data, and you are always the visitor location register that is physically closest to you always gets the copy of your subscription data from the home location register, and uses that so you don't have to, every time you make a call, the home location register doesn't have to be asked for your, is he allowed to make that call and stuff like that, but it stays in the area. So for example, if you have a subscription in Germany and your home location register can be anywhere in the country, let's say in Munich, and you are currently in Berlin, then the visitor location register in Berlin tells the HLR, hey, this guy is here now, please give me his subscription data, and he gets a copy of that subscription data and can use that from that point on. So next to it, often those two components are combined, is the MSC, the mobile switching center. That's basically the switch that routes your calls and messages and stuff like that. And then on the left-hand side is the base station subsystem, meaning all the radio stuff, the cell towers, base station controller, stuff like that. So the most important things that you need to remember are your home database, the visitor database, which always keeps a copy of your subscription data, and the mobile switching center, the switch. So what does the network know about your location? So the location of the cell tower is also a pretty good approximation of your own location if you have your phone with you. But that information is only known to the network you are currently logged into. So meaning if you are in Austria but you have a, I don't know, Netherlands subscription, then your operator in the Netherlands just knows, okay, this subscriber is currently in Austria, but he doesn't know what cell tower you are using. That at that point, only the network operator in Austria knows. So you probably know those locate my phone services, where you register on a web page and say, okay, this is my phone, and you have to authenticate somehow and assure them that it's really your phone, the number you are entering, and then you can later enter that number there, and it tells you pretty exactly with the radius of, I don't know, maybe 500 meters in the city where your phone is. But yeah, that only works for your own phone number, and it only works as long as your phone is in the home network. As soon as you're in a different country, it doesn't work anymore because your network operator just doesn't know where you are exactly. So yeah, the other exception who can access this data is law enforcement. Meaning the police who can, you call the operator, if they want to know where you currently are, they also have to call the operator that you are currently using. Meaning if you are in another country, they can just call your home operator and he will tell them, sorry, we don't know where he is, please call the operator in that country to know. So, the question is, can somebody who just has SS7 and map access, that could be anybody, because any operator in the world, because all operators or most of the operators are connected via SS7. So could any operator at the other end of the world who has SS7 and map access find out your location? So for that, to know, we have to look at what services can be initiated from almost any place in the world. So first, there are of course voice calls, and the other thing that almost always works are short messages. So other than that, I mean video calls or MMS or stuff like that, most of the time just works within your network or within your country. So we have to take a look at voice calls and short messages to see if some operator or some evil spy who somehow has resources to access an operator can find out about you based just on your phone number. So this is how a call setup works in mobile networks. Back there, on the left-hand side, we have the evil spy, or just another network operator, who sets up a call to you. And that call setup message travels directly to he has to send it to the gateway switch, to the gateway mobile switching center of your home network. So the gateway switch then asks your home database, hey, tell me, where is this guy and how can I reach him? Your home database then asks the visitor database to provide a roaming number. You always need a roaming number to actually route a call. A roaming number is something like your normal phone number, but just a different phone number that gets assigned to you for for the time of your stay in that area. Okay, your home database sends that back to the gateway switch, and the gateway switch then forwards the call setup message, which is then forwarded by the switching center to the phone. So that means the guy over there on the left, he just sends the call setup message to the gateway switch, and he doesn't get any further information about your location because the gateway switch handles the call setup then, because it forwards the call setup message. So meaning we cannot learn anything from a simple call setup message about your location. So let's look at short messages then. As you can see, short message is pretty different because what happens here, so here with call setup you have the send routing information that's sent by the gateway switch to the home database and then back. And when you send a short message, the guy in the SS7, the spy in the SS7 network, or just another network operator who wants to deliver a short message to your phone, in the normal case, he directly sends a request for routing information for that short message to your home database. And your home database gladly answers that request for routing information and says, okay, here you go. That guy is currently using that network and that switching center, and then the other operator can send a forward short message request directly to that switching center, which in turn then sends the message to your phone. So you might notice that those two actions are not really connected to each other. So normally you would send a request for routing information, and with that routing information send the message, but there's no obligation to do so. You can just ask for routing information and you get the routing information back, and that's it. You don't have to do anything further. You don't have to send a short message. So let's take a closer look at the send routing information request. So as I said, there's no correlation between requesting the routing information for a message and actually sending a message. And SMS are sent directly to the switching center that you are currently using. So a successful send routing information for a short message request returns your IMSI, your International Mobile Subscriber Identity. That is like your real phone number. So the phone number you're normally using is just a mapping to this IMSI number. Meaning, if you, for example, if you lose your SIM card, you can just go to your operator, ask for a new SIM card, and within minutes or at least hours, your phone works again. And that is because in your home database, they just need to change the mapping. Okay, that phone number now uses this SIM card. So the IMSI is like your real phone number, the number of your SIM card, and that's globally unique. And you get that number returned because to send short message to the switching center, you have to address them to the IMSI, not to the normal phone number. So it also returns the global title of the MSC of the switching center that you are using. Global title is just a fancy name for phone number. So it returns the phone number. Of course, you cannot phone the MSC, but it's just a normal phone number, a number that looks like a normal phone number. And it also probably returns a user error that could be, for example, absent subscriber, meaning your phone is currently off. So I don't know, some might still remember my talk from the 18C3 about SMS features, where I also presented a feature where you could send silent SMS to somebody to find out when he switches his phone back on, because you get a delivery report as soon as the SMS is delivered, but those silent SMS are never shown on the display of the phone. So this is a more elegant way to do it, because you get that information already back from this request, so, but nothing ever happened at the user side. So you get already back the information, okay, the subscriber is currently absent, and if you still send a message there, it will fail because the phone is off, and you will get notified by the MSC as soon as the phone is switched on again. So yeah, it's even more elegant than sending a ping or silent SMS. So the mobile switching center handles calls and SMS, and it can only handle a certain amount of calls. So in big cities, there might be more than one MSC for each network, while in the countryside, one MSC might serve a really, really large area. And so the global title, the phone number of the switching center, already tells us which country you are currently in, because it starts with the country code. So if we go back to the demonstration, MSC, this is the phone number of the switch, and we can already see it starts with 49, so that's the country code for Germany, and so we already know just by looking at that number, okay, that guy with the UK phone number is currently in Germany. So then maybe we can also identify the network, because in some countries, also in Germany, the mobile network can be identified by their area code. So this is also the case here. 171 is the network, is the area code for T-Mobile. So you're currently using T-Mobile, right?
Yeah, UK T-Mobile as well.
Yeah, okay. So he's using T-Mobile. And so other than that, the numbering is completely operator internal. But that doesn't mean we cannot get further information from the number by looking at it long enough. So let's see some examples. For T-Mobile and Vodafone Germany for different cities. Those are not the only MSCs in those cities, at least not in Berlin and Hamburg. And I just picked some of them at random. So some of you, the ones from Germany, might probably notice that T-Mobile uses in its MSC numbering always the first digit of the area code of the area the MSC is serving. So meaning, for example, Berlin's area code is 30, and at that position there we have a 3. So if you know that, you can just see from the MSC number roughly at least which area somebody is currently in. Vodafone, on the other hand, uses the first digit of the zip code or postal code of that area. So Berlin postcodes all start with 1, and they all have a 1 at that position. Yeah, but as it goes, of course, those numbering schemes are also broken once in a while. For example, it seems that Vodafone is not able to have a 0 at that position, but there are postal codes in Germany that start with a 0, so they just get a different number. And yeah, there are some MSCs that just have different numbers. And also, they notice Vodafone seems to have started a new numbering scheme where they also use the first digit of the area code. O2 also has a numbering scheme, but it's one of their own. But you can see from the number, you can still see if it's serving a northern or western area of Germany, or eastern or southern. And E Plus doesn't seem to have any numbering scheme at all. So, but yeah, that's still not good enough. We want to find out more. So the idea is, if we already have a lot of mobile phone numbers and already know their location, we could query the network for the current MSC, so send a lot of send routing information requests, and so create a MSC to geolocation mapping. Big thanks to Erdgeist. Yeah. Who provided a decoded copy of the Das Telefonbuch CD. which are the complete German white pages, complete with also geocoordinates of all the phone numbers in there, at least the ones that have addresses listed. So what I did, I sent tens of thousands of maps and routing info for short message requests for numbers from the phone book. And yeah, I did those requests mostly at night when people are at home, and also removed the obvious errors, because if you have, I don't know, you have 100 hits in Berlin and 1 hit in Munich, that doesn't mean that MSC is also serving Munich. It means somebody from Munich is currently in Berlin, so that's an obvious error. Okay, I created some maps from that. On those maps, the errors are not removed, so you can see them. Okay, this is, for example, one T-Mobile MSC, obviously for Berlin. As you can see, yeah, it pretty much covers the whole Berlin area, and some people from Munich and Hanover and Hamburg and so on are also in Berlin. So this, on the contrary, oh, I don't know if you can see that there in the back. There are little red dots sprinkled over Brandenburg, and fewer dots in Berlin. So this means this MSC is serving the whole Brandenburg area, so the area around Berlin. Okay, next we have an MSC for Hamburg from Vodafone, and one for Munich from O2. So, and then we have something interesting. This O2 MSC serves whole Germany. So this is actually as soon as you have, does somebody have an O2 multi-card here? More than one SIM card for his O2 number? Yeah, okay, some people, you are using this MSC all the time, no matter where you are. So this is their way of saying, okay, we don't know yet where this message is going to be routed, to which SIM card, so give me all the messages, everything is going to go over this MSC, and that will then decide where to route these messages. Okay, we also got a mapping for the Netherlands, and yeah, other countries would also be possible if there are just decoded phone books available. So now you might be saying, okay, no one I know is a network operator, I don't have SS7 access, I didn't even know what SS7 was before today, and nobody I know has SS7 access. So I can be pretty sure no one who would care finds out my location, right? Wrong. As I found out, there are several companies offering a lookup service where you just send them a phone number, they perform the send routing information request and send the IMSI and MSC they receive from your home database back to you. So, and the cost per request is in the low single euro cent area, so not very expensive. So yeah, I was asking myself, why are they selling this kind of service? Because you don't get back this web interface I did myself. What you get back is just the IMSI and the MSC number. So who uses the service? And yeah, I finally found out, because and also they're not selling, you cannot go there and say, okay, I take one request, you have to take something like 10,000 requests, and you get a rebate if you take 1 million requests. So nobody wants to make 1 million requests to find out locations. So after a bit of research, I found out you could use this to send free spam SMS. So let's say evil spammer wants to send spam SMS and he doesn't want to pay for them. So he has SS7 access, so he sits, I don't know, somewhere in some little country connected to a small network operator that has SS7 access. And he has the equipment to also send those map requests, those send routing information for short message requests, but there are no roaming agreements with any other operator, so they just don't answer his requests. So, but as you might remember from the beginning, SS7 doesn't have any authentication built in. And what you also might remember is the actual sending of the short message is just like sending a single UDP packet in the IP network. So you don't care for an answer, you just send the message there, and you don't care where the answer goes because the message will be delivered then. So just like with UDP or IP, you can write any sender in there, and but to be able to find out where to send this message, you need to have the routing information. You need to know what MSC the target is currently using. So, and this is that. For that, you normally would need roaming agreements with those operators, because you need an answer back. And of course, they don't answer if you don't have a roaming agreement. So he just uses one of those services, asks them for routing information for phone numbers he wants to send spam to, and then uses this routing information to send the short message via his SS7 link. And as a sender address, he just puts in there some SMSC, short message service center, of some other network that has a roaming agreement, and they will be billed for this short message. So, meaning some other network pays the bill, and evil spammer can send free spam SMS. Okay, so disclaimer, there might be a completely valid business case for this service that I just didn't spot. So I don't want to accuse anybody of advancing fraud or something like that, but I know this scenario that's really happening. And that's also the reason why the network operators are doing something against it. And that's also the answer to, I don't want to be located, what can I do? So the network operators are currently thinking about implementing a technique called SMS home routing. So as you might remember, voice calls always go over your home network. So, but short messages go directly to the network you are currently using. So they want to make short messages more like voice calls, and that they all are always routed over your home network. So instead of directly returning the phone number of the switch that you are currently using, the send routing information for short message request returns the phone number of an SMS router in your home network. And also, instead of your IMSI, a random correlation ID will be returned. And that will help operators to find out which map send routing information request belongs to which actual sending of a short message. So they can just look up the correlation ID, and the SMS router will then replace that with the real IMSI and forward the short message. So operators are not doing that to enhance your privacy. I mean, that's also mentioned in that 3GPP document, but of course their first concern is to prevent fraud, to enable value-added services, whatever that means, and to enable lawful interception of SMS when you are that you receive when you are in another country. So, because currently, if you are, let's say, you have a Swiss subscription and currently you are in Italy, and somebody from Germany sends you a short message, the message travels directly from Germany to Italy and never touches Switzerland. So police in Switzerland cannot read that message. Of course, every police in the world want to read those messages, and so they are implementing this also to enable lawful interception. So this is again how home routing will work. The sending network will send a request for routing information like always, but the SMS router will then answer with fake routing information that just contains data for the SMS router itself. Then the sending network sends the short message to the SMS router. The SMS router will replace that fake information with the real information that's normally contained in the routing information request, and actually will then forward the short message to the MSC you are currently using, and that will forward it to the phone. So yeah, until home routing is in use. So yeah, as I said earlier, for example, if you are using O2 in Germany, what you can do is you can call them and say you want to use multi-card, and for a fee, for a one-time fee of 25 euro, they will send you another SIM card, and then you will use that that one MSC that's used for all multi-card customers, so you won't be it won't be possible to locate you anymore with this method. Yeah, the other possibility is you could let your operator block incoming SMS for your phone number. Not a very good possibility. Also, you could, of course, always switch your phone off. So, yeah, but home routing, I don't know when they will implement it, but it's currently being standardized, and I don't know, I think maybe 1 or 2 years or something like that. So, on the other hand, as you remember, your voice calls always go over the home network. And yeah, the operators are noticing people are traveling around a lot. And that's a lot of traffic. For example, if I'm in Los Angeles currently and you are in Tokyo and I want to call you, but you have a German phone number, then the call goes once around the world currently because it has to go over the German network. It would be much better if it would go directly from Los Angeles to Tokyo. It would be much shorter. So that is what optimal routing will be. It's already standardized, and it makes it possible to route calls directly to the network that you are currently logged into. But that, of course, can only work if the entity that sets up the call has a way of finding out which MSC you are currently using. So there is, again, that possibility to find out the MSC you are using and to locate you. Okay, so far optimal routing is not widely used, or I don't even know of a single network that's using it. At least in Germany, no networks are using it. And yeah, of course, charging issues have to be worked out, because if your calls don't even touch the network anymore, that has to bill for them, has to pay for them, or has to issue a bill for them, then there are some issues to be worked out. So I don't know when this will be implemented or if it will ever be implemented, but that would then be another way to find out your location. So again, call setup with optimal routing. Your home database gets asked for routing information. It gathers the routing information it needs and sends the routing information directly back to the network that asked for it. So that's much like, so short message they're converting short message sending to be more like voice calls, and voice calls to be more like short messages. So, and then the call setup message, initial address message that's below here will go directly to the switch you're currently logged into. Okay, that's it. Thank you very much. Okay, first of all, before you start asking questions, I won't tell you which those companies on the web are that sell those services, but you can Google them yourself, and with the terminology from this talk, that's no problem.
I was wondering, is this technique exclusive to GSM, or can you use Hello. I was wondering, is this technique exclusive to GSM networks, or does it work on CDMA networks in the United States as well?
I have to say I don't know. If you have a CDMA phone, we could try, but or know somebody with a CDMA phone.
I'll give you a CDMA phone number if you want.
Yeah, okay. We could try that. Yeah. Okay. So because I don't know if those the MAP protocol is not exclusive to GSM. As far as I know, it's just an extension to SS7. So it could also be that it's used by other network operators. Hmm?
Do you want to see a phone number?
Yeah. Okay.
You can
There's some more questions.
I have a question.
Yeah.
This roaming number,
Yeah.
the MSISDN for the network
Yeah.
you're in currently, is there also a service where you could find out that number?
I
for
didn't
yourself?
find one so far. You have to
Because that would be nice, because then people could call me on a German number.
Yeah,
if I'm
yeah,
in
yeah.
Germany.
I know. It would be really
Yeah.
nice, but of course the network operators take good care that you don't get to know that number. Okay. Any more questions?
How are you doing? Just wondering, how much information can you infer from the mobile number you're given when a call is made to you in another country?
Where are you?
Here, sorry.
Okay. Okay. Could you repeat your question?
When you make a call to a number that's roaming in another country, and the service returns the mobile number equivalent to the roaming number, how much information can you infer from that mobile number, at least the country, can't you? So you could tell anyway what country the person's in, even if they are roaming.
Sorry, I didn't.
You said at the current system,
Yeah.
if you're roaming and someone places a call to your number,
Yeah.
that a mobile roaming number is returned to them, that they call that.
Yeah. Right.
So how much information does that number give away?
The roaming number you mean? Okay, so the roaming number is just, as far as I know, just a normal phone number in the just a normal mobile number that's in a number space on that network. That's not used for normal phone numbers. So yeah, I don't know that you can. I don't know if you can get any further information from that number. But if you knew that number, you could, of course, as Rob just said, you could call directly that number and wouldn't have to pay roaming charges for calling that guy.
Hello?
Yeah.
Just one question about optimal routing. Wouldn't they lose the capability of lawful intercept if they are going to implement it?
Yes, that's what I.
So should we fear it? Or wouldn't be the agency do much more pressure on standardization to stop it?
Well, I'm sure they find a way to somehow still intercept the calls. But yeah.
Optimally route whatever is intercepted, which means
Yeah.
you could detect interception by just seeing if you're going through your home or not.
Exactly. So Rob is just saying if you are being intercepted, then your call will not be optimally routed. So when you
Good point.
when you can find out if a call is optimally routed or not, you could then see from that information if the call
Yeah, we
is being
should do
intercepted.
some latency detect.
Yeah,
somehow.
definitely.
Hi. You said that, well, you've been sending thousands of routing information requests, but
Yeah.
how do you do that? Can you do that from a phone that you modify, or do you have access to a telco network?
No, so SS7 protocols are just used between network operators. So it's somehow their internal network. So SS7 protocols never reach your phone. So you have to have SS7 access or just buy those requests from one of those services I mentioned earlier. Okay, any more questions?
Yeah, I wonder why they get access to these SS7 messages at all. These operators that you've been using. Why do the phone companies let them do this kind of stuff?
Good question. So they are usually also sending companies who are offering SMS large accounts. So meaning you can use them to send lots of short messages. So and they are connected directly to operators with SS7 access. So they just have to have the technology to do these kinds of requests to deliver the short messages. So I think they're just, I don't know, they just started selling the service and the network operator probably doesn't even know about it. So that's, I don't really know, but that's how I think it goes.
As far as I know, SCDP is a part of the SS7 protocol suite now, and you told me that SS7 is a walled garden, yeah, so only the providers can access it. But SCDP is in the wild. That's accessible from the internet. I mean, you just port scan that. It's like a layer 4 protocol. Instead of TCP, you scan for SCDP, and that's working. I have a list of a few posts out there.
Okay, we should probably talk later. Okay, thank you.
Mike, hinter dir war noch einer.
Thanks. One question, what should be typed into Google to find these companies who offer the service?
Hey, you heard the talk and it was all in there. You will find it out, I'm sure.
Okay, thanks.
If you can't work it out, you shouldn't have it.
Yeah, exactly.
So where's the list of politicians' phone numbers?
Yeah, give me one.
Hello? Yes. Yeah, how hard is it to get access to an SS7 access as a private person? Do you know that?
Well, you have to. Well, I think it's mostly a matter of money.
That's bad.
Yeah, it's not really cheap, and yeah, you have to assure them that you're a network operator, and well, you probably won't do it if you're not a network operator and making serious money from it, because then it's too expensive to get. But yeah, I don't know exactly how easy it is in some parts of the world today to be a voice over IP operator that gets SS7 access. So if somebody has more insight here, I would be glad to know.
I would assume that it's easily or equally easily as getting BGP feeds in backend, say 2000 or something, as a private person. So you need contacts. That's the easiest way.
Okay. Nobody? Okay. Then, thank you very much.